Okay, today we're going to talk about dead reckoning. This is part of the ACS. I don't have the section number handy, but it will come up during your check ride, presumably. I don't think the every DPE is fully switched over to EFBs, electronic flight bags, so I think it's a good idea to actually know how to do this, and then like in the scenario where your like say your iPad dies or your like your G430 in the aircraft doesn't have power or is not working, or any number of scenarios where you might actually need to dead reckon your way to a safe to a landing place, or maybe even possibly to your destination. So to that point, I put together an exercise. I'll kind of talk you through what you're looking at here, and then I'll go ahead and crunch one or two of these live. So you can see that we've got a fake sectional at 1/500,000th scale. So that directly correlates to your protractor. I think it's a little challenging because there's no protractor on the screen, so you kind of have to put a plastic one on your monitor to be able to calculate it, which is exactly what I've been doing with this exercise to validate it. But anyway, so we've got our sectional, and then we've got a mechanical E6B on the wind side. So if you're familiar with, like, I got my physical one, it's cardboard and plastic from the Jeppesen course. I think it's, again, super valuable to actually learn this stuff, how dead reckoning, used to work and still to this day holds up when, all the modern electronics fail. So you've got your E6B and a Whiskey 360 calculator, and then our compass card, which are, the primary inputs, the primary tools that you'll need. The inputs we've got down here, and we'll kind of talk through as we go through the scenario. So in this one, we're flying or navigating from Cedar to Long Lake. So you can see we've got Cedar Field, KCDR, and we're going to Long Lake. That's one of our legs that we're going to compute true course, wind correction angle, true heading, magnetic heading, and compass heading. All five, and then I'll explain along the way. So I'm literally, you can't see this, but I'm actually putting the protractor on the correct side, so the 1/500,000th side, and I'm going to measure from KCDR. I'm just going to put the edge on one of these vertical lines, and it looks like so 0, 10, 20, 30, 40, 50. I'm going to say it's about 52. And so we can just mash that in and check, and the simulation seems to think that's good. And from there, what we need to do is come over to our E6B, and we'll start by plugging in the wind, which is 090 at 22 knots. So we'll just grab this guy here and set it at 090. Easier said than done. There we go. So we've got 090, and it's at 22 knots, and there's just a nice little button to mark what it knows the wind to be. In theory, we would, like in real life, we would be, I just put a piece of tape on the E6B and use a pen, and then I can move the tape around for every calculation. But we'll just mark it at 22. So you can see we have a little grease pencil mark there at 22. And then we take our TC number, the 52 from the previous step, and adjust. There we go. So we've got 52. So that shows us our wind correction angle. And we could also, if we wanted, calculate our ground speed from this. So we would assume like 110 knots of as our cruise speed, and we'd put the wind mark right there on 110, and that gives us about 93 knots of ground speed. That might come up, and that definitely is part of your nav log planning. I don't know if you saw my other video with pre-brief where ground speed is part of the calculation for total fuel and duration, but that's another video. So now that we've got that plugged in, we can actually compute our wind correction angle. And so it's between the 5 and the 10, but closer to the 5. So I'm going to say, and it's on the right side, so that means that it's a positive number. So we can say +7, and then we can just check that answer. So that's looking good. And then from there, we would just add these two. So 52 plus 7 is 59, and we'll check that. And then we need to calculate the magnetic variation from this 8 degree, and you can't really see it, but it's an 8 degree east isogonic line. So east is least, which means we would subtract 8 degrees from our true heading. So that would be math 51 degrees. We can check that. Perfect. And then for compass heading CH, we need to read from our plane's specific compass card. We've got one mocked here for you, but essentially this is the distortion that the airframe itself, made of metal, causes to any compass reading, and it's a constant number that we can just apply. And so our magnetic heading is 51, and so we're between this 30 and 60 variation, but closer to the 60. So we could say anything between 2 or 3. So I'm just gonna say it's closer to 60, so we'll do 3. And because it's an east variation, we need to subtract. So that would be a compass heading of 48, and we can check that number, and that shows up on the compass. Just to go through that again, we can look at another example. So in this one, again, we'll erase our E6B, and in this one we're going Ridge Tower to Millville. So you can see Cedar Ridge Tower, and I'm just gonna put my protractor there on the line, and that looks like about 10, 20, 30, 40, 50, 60. I'm gonna say that's 1, 2, 3, about 63. And the computer likes it. And then we just go back over to our E6B with, in this case, the wind is 220 at 25 knots. So we'll just go back to 100 here, just a practice. Oh, that's really hard to be precise with. Anyway. And then we'll set it to 220 degrees. Excellent. And we can mark it at 25 knots. It does that for us. And normally, again, that would just be a pen or pencil mark on the calculator, or on the piece of tape on the calculator. And then we need to put in our TC of 63. So we can scroll all the way around to 63. There we go. And so that tells us, and then of course we would set the wind line on our cruise speed, or whatever speed we're going to fly that at. So I'm just going to move that up to the 110, which tells us our ground speed. In this case, we have a tailwind, so we'd be 133 knots. It's a little bit faster than the indicated like true airspeed. Sorry, I mixed those up, but it would be like 22 knots faster than our true airspeed. And then we can see that that line is right there on the 5-degree mark. So we know that our wind correction angle, and it's on the right side, so we would say +5, and we can check that here. And so from there, our true heading is, again, just math, so we'd be 5 + 63 gives us 68. And our magnetic heading, in this particular map, it shows a 12-degree west isogonic line, which means east is least, west is best, so we would be adding 12. So that would be roughly 68 + 12, correct. And then our compass heading is, we're going to derive that from our compass card. So 80 here is roughly a -2-degree variation. So we'll say that's 78 is our compass heading. And that's it. It's really that easy. If you've got there's plenty of apps that'll calculate this for you. There's digital E6Bs that you can carry with you in your flight bag, but ultimately knowing the process, knowing what all the variables are, where to get that information. You've got your sectional to calculate your TC, your true course, and then you would presumably like tune into the AWOS, to the AWOS, to get your weather, or you could check aviationweather.gov or 1-800-WXBrief.com to get an official wind reading. But and then from there, it's all just math. I don't know anyone that can do this E6B calculation in their head, but if that's something you're into, that's definitely possible. But if you have any questions, leave a comment or send me a message. Thank you.